So welcome everybody to this latest video on 162 Maths, and in this video we'll be covering the AQA GCSE Maths revision list of 2022, looking at the Foundation Paper 2 Stats and Probability section. Now as always, there'll be a copy of the questions that we go through in this video for you to have an attempt at before watching this video or during, and you can do that by clicking on the link in the description below. So before we get started working through some example questions, let's just have a closer look at this advanced notice of the statistics and probability from the Paper 2 Foundation paper. Now, I would say with this section being very brief, I think in terms of predictions, I reckon there'll be only about 4 questions relating in total to statistics and probability. And the reason for that is many of these topics are generally found as one question. So one part may be part A, the next topic may be part B, and it's merged from there. Now I would say the individual topics are probably pie charts. So when you're revising this topic, make sure you're able to constructed pie chart from scratch when you're given a circle, finding the angles, but also working backwards where you're given a complete pie chart and you then need to answer questions related to the pie chart in terms of finding out what the angles would be or finding frequencies. Now when it comes to range and mean, again, there's several individual questions you can have on this. Usually it may be worth 1 mark. Sometimes if it's working backwards where you're given the range and the mean and you need to find out what one of the individual results are, they would probably be more your big mark questions. So when you're revising the range and the mean, don't just simply go in one direction of giving a list of numbers and working out range and mean. You also want to work backwards where you're given the range and the mean value to find out what one of the individual scores are going to be. I would also recommend revising how to compare data as well. So with the mention of being mean and range, these are 2 characteristics of when you're comparing 2 sets of data. So for example, class A and class B, you're given a mean, you're given a range, and you need to talk about the results. So remember that mean is on average which one is better. That could either be the higher value or the lower average will be better. Then the range is a measure of consistency. Whichever set of data has the smaller range will have greater consistency. Moving on to probability, relative frequency and expected values are very much merged into one question. So the first part is recognizing how do you find the relative frequency. Now with probabilities, remember there are 2 types of probability you can get. One is theoretical probability where you're using maths to find the probability. The next one is experimental probability. This is where you conduct an experiment and you're working the probabilities based on real events. So this is where relative frequency comes in, where you are to work out the probability. It's how many times the event actually happened over the total number of times that you measured it over. And again, expected values is where you're multiplying the relative frequency by the total number of trials. The last one, looking at tree diagrams, again, it's a very much a higher level topic based on the questions that you could get work with, but I would say at foundation level you're only going to be working with independent events where all the probabilities on your tree diagram are going to be the same. So for this topic I would revise how to complete a tree diagram, how to label a tree diagram, reading information from a tree diagram, and particularly working with and or rules. So now let's have a look at some example questions that cover all the above topics. Now a little reminder is you can have access to these questions by clicking on the link in the description below, and I strongly recommend that you do that so you get an idea of what you know and what you don't know. So let's move on to question 1. So question 1 says that a shop sells ice creams. Each ice cream has 2 scoops. The possible flavors are vanilla, strawberry, chocolate and mint. The 2 scoops can be the same flavor or different flavors. List all the possible options for the 2 scoops, and this one's worth 2 marks. Now for this, again, we can just abbreviate by using the first initial, which is the letter. So here I can have vanilla, and then I'm going to go through all the 4 options. So I can have vanilla, strawberry, chocolate, mint, and they're all the options of selecting vanilla first. Then if I go for strawberry next, so again, VSCM, and stick an S there. So that's all the options with strawberry first. Then going for chocolate first, so again VSCM, and then CCC, and then finally for mint VSCM, and then mint 4. So altogether there are 16 options, and doing it there we've got 2 marks. Although we've got 16 possible answers, it's done in under 2 minutes because we did it in a systematic way rather than just randomly picking 2 options. Now for question B, it says in 1 hour the shop sells 180 scoops of ice cream. The number of scoops for each flavour is shown in the table, and the question is asking us to complete the pie chart to represent the data. Now, even though this question is on a calculator paper, we can do it without a calculator because angles inside a circle add up to 360. So that means that 1 scoop equals 2 degrees. So all I need to do is multiply each of these numbers by 2 and I'll work out the angle. So that's going to be 90, that's going to be 150, this is going to be 100, and this is going to be 20. Now the general formula to work out the angle in a pie chart is the frequency divided by the total frequency, and then we multiply that answer by 360 because we're looking at angles in a circle. So here for the vanilla, so just as an example, if I wanted to work out vanilla, I'd do 45 divided by 180 multiplied by 360, and on the calculator it would give me an answer of 90. So then from this, all I then want to do is to plot or to measure each of these 4 angles. So for the first one, it's going to be 90, and again you should be using a protractor, which I know I'm going to struggle. That should be 90. Now it's also important that you do show that you've calculated these angles somewhere. Then 150 is going to be roughly around there, so this is going to be strawberry. And again, always worth making sure that you are labeling your sectors. So 20 is going to be roughly like so, so that's going to be mint, and I would say that that's probably going to be a little bit bigger because that looks more like 90, but actually it's about right. And this angle here should be 20 degrees, this angle here should be 150 degrees, and this angle here should be 100, and that is chocolate. So it should look, now yours should be drawn a lot more accurate than mine, but I would say generally that's what it should look like. Moving on to question 2, it says in an election there were 4 candidates, J, K, L and M. Fran is drawing a pie chart to show the results. The sectors of J and K have been drawn. Twice as many people voted for L as voted for M, and the question is asking us to complete the pie chart. So we notice that this is 90 degrees. So what we then need to do is work out what this angle here is going to be. So it's going to be 360 minus 72 minus 90, and if I reach for my calculator to work that out, I get an answer of 198. So now what I need to do now is, looking at this statement here, I've got L and M, and there are twice as many people voted for L as voted for M. So what I then need to do is share 198 degrees in the ratio of 2 to 1. So from this, I do 198 divided by 3, which gives me 66. So then 198 divided by 3 equals 66 degrees. So I multiply that by 66, this by 66. So I'm going to get 66 degrees and 132. So what I then need to do is measure these angles. So let me just get rid of this little mark here. And then drawing a line. Again, yours should be a lot more accurate than what I'm going to be doing here. So this angle here should be 66 degrees, and that is M. And this angle here should be 132, and that is going to be L. Moving on to question B, it says altogether 16,200 people voted. How many people voted for J? So for this, we need to do 72 out of 360. And we multiply that by the total number of people, which is 16,200. So 72 divided by 360, which is a fifth, times 16,200, and we get an answer of 3240. And again, really important you do show as much working out as you can. So for question 3, the pie chart shows information about voters in an election. It says that 3,360 more women voted than men. Work out the total number of voters. So for this, what we want to work out is that the women angle is going to be 250 degrees. Now we know that the difference in terms of the two angles is going to be 3,000 and 360. So the difference is 3360, and the angle difference is going to be 140. So that means then, working out the difference, we do 3360 divided by 140. So 3360 divided by 140 gives me an answer of 24. So that means that 1 degree equals 24 people. Now the question is asking for the total number. So we do 360 multiplied by 24 and typing that into the calculator, I get an answer of 8,640. Moving on to question 4, it says some players were asked the shirt colour of their football team. Each answer was either white, blue, red or green. The pie chart is drawn to represent the answers. 2 of the sectors are shown. The number who answered red is 3 times the number who answered green. Complete the pie chart. So again, this is looking at ratios. So the first thing we need to work out is how many angles is left. So 360, take away 75, take away 165, and that gives me an answer of, and let me just work that out, gives me an answer of 120. So what I then need to do is, we've got red and we've got green, and it's in the ratio of 3:1. So what I then need to do is share 120 degrees in the ratio of 3:1. So I do 120 divided by 4, which equals 30, and I'm going to multiply each of these numbers by 30. So the red angle is going to be 90 degrees and the green is going to be 30 degrees. So 90 degrees is probably the easiest one for me to draw. So if that's 90, this is going to be red and this is going to be green, and this angle here should be 30 degrees and this angle here should be 90. Moving on to B, it says there are 600 players altogether. How many answered white? So again, very, very similar to the previous question. So it's going to be 75 degrees over 360, which is the proportion. And then we're going to multiply that by the total, which is 600. So 75 divided by 360, which is 5 over 24, multiplied by 600, gives me an answer of 125. Moving on to question 5. So now we're looking at averages and ranges and means. So here it says, here are a list of numbers, and it says write down 3 numbers from the list that has a median of 7. Now the median is the middle number, so that means that this number here must be 7. So for this number I need to pick one of the numbers that's smaller than 7. So again, either picking any one of those 3, so let's just go for 0. And then for this number here, I want to pick a number that's bigger than 7. So it's either going to be 12 or 29. So let's just go for 12. So again, this number can either be 0, 3 or 5. This number must be 7. And this number can either be 12 or 29. The next one says write down 3 numbers from the list that has a range of 7. So again, what I need to do is make sure that when I take away the biggest number from the smallest, the answer is going to be 7, with a number that's in between being in the middle. So here, if I start with 0, I've got 0 plus 7, which is 7, so that would work. So let's go for 0 and 7. Then in the middle, just need to pick a number that's between those. So let's go for 3. So I could have picked either 3 or 5. But this one here is going to be 0. Other options I could have picked are 5 and 12. So I could have gone for 5, 7 and 12 as a possible answer, and that would be correct. Or I could go for what I chose of 0, 3 and 7, or 0, 5 and 7. The next one then says find 3 numbers from the list with a mean that is a whole number. So what I need to do is find 3 numbers that when I add them together, it's going to be a multiple of 3. So here we could go for 0, 3 and 12. So that would give me a multiple of 3. That's one possible option. I could go for any other, so basically where you add up all the numbers, so add up 3 numbers and if it's a multiple of 3, it's correct. The next one then says find 3 numbers from the list with a range that's double the median. Write down the value of the range and the median. Now for this one, it's potentially just a case of playing around with the numbers, but for here I would say the 3 numbers are going to be 5, 12 and 29. So if I just write down those numbers here, so again looking at the range, I'm looking at a range of 24 and the median is going to be 12, and as you can see there that the range is double the size of the median. Then looking at question 6, it's the table shows 2 sets of data, and it says for part A, Liam says that set A has a higher mode. Is he correct? Now for this, it's really important that you're able to establish that the frequency helps you find the mode. So you're looking for which result has the higher frequency. So for set A, the mode is going to be 6, and for set B, the mode is 4. So yes, he is correct. Then moving on to B, it says that Liam says set A has a larger range. So the range of A, which is going to be 7, take away 2, which is 5, and the range of B is 6, take away 3, which is 3. So again, yes, he is correct. Question 7 then says here are some numbers, and the question is asking us to circle the range. Well, again, the numbers are nice in order, so it's going to be 17 minus the lowest number, which is 5, which is 12. Moving on to question 8, it says the factory makes kettles. 4 samples of kettles are tested for faults. Each sample has a size of 200. Here are the relative frequencies of the faulty kettles in the sample, and the question says work out the range of the number of faulty kettles in the 4 samples. So for this, all we need to do is multiply the relative frequency by the total number, or the total frequency. So for P, it's going to be 0.03 times 200, and again if I type that into my calculator, I get an answer of 6. So then for Q, it's going to be 0.035. I don't know what number that is, so let me just write that a little bit neater. So 0.035 times 200. So here 0.035 times 200 gives me an answer of 7. Then for R, 0.015 times 200. So 0.015 times 200 equals 3. And then S is going to be 0.01 times 200, which is 2. So then what I then need to do is work out the range of these numbers here. So then the range is going to be the biggest number, which is 7, take away the smallest, which is 2, so the range is 5. Then moving on to question 9, it says that a spinner can land on red, blue or green. After 350 spins, the relative frequency for red is 0.18, the relative frequency of blue is 0.62. Work out the number of spins for it landed on green. So for this, all we need to do is take away all of those from 1. So I've got 0.18 minus 0.62, and take away all that from 1. So 1 minus 0.18. minus 0.62, and that leaves me with a fifth, which is 0.2. So then from this, I've just got to multiply 0.2 by 350, and that should give me an answer of 70. Now it's really, again, really important that you show you're working out, so you get 1 mark for working 0.2, 1 mark for multiplying the answer by 350, and then 1 mark for your final answer. Moving on to question 10, it says the result of a game is win, lose or draw. After 80 games, the relative frequency for a win is 0.4, relative frequency for a loss is 0.25. How many games was it resulted in a draw? So again, very, very similar to the previous question. So here, 1 take away 0.4 minus 0.25, and that's going to give me 0.35. So then I'm going to do 0.35 multiplied by 80. So 0.35 times 80 gives me an answer of 28. Moving on to question 11, it says that a coin is thrown 50 times. It lands on a heads 31 times. Write down the relative frequency it lands on a head. So the number of times it landed on a head is 31 out of a total of 50. That can't be simplified, so I can leave it as that. Now you can either write your answer as a decimal, or you could write it as a, so leave it as a fraction, sorry, or write it as a decimal, and that as a decimal is going to be 0.62. The next question then says, Raj says the coin is biased towards a head. Use the data to give a reason why he may be correct. And the reason for this is because if it was fair, the probability of getting a head should be 0.5. So something along those lines, something along the lines that the probability of getting a head is higher than 0.5. So something along those lines would be absolutely fine. Question 12 then says that a coin lands on tails 200 times. The relative frequency of tails is 0.4. Work out the number of times the coin was thrown. So here it says 200, so it lands on a tail 200 times. So if I then do 200 divided by 0.4, because I want to work out the total number of trials. So 200 divided by 0.4, and that gives me an answer of 500. And the reason again for that is because the relative frequency is equal to the frequency divided divided by the total number of trials So then from this, if I'm wanting to work backwards, it's just a case of taking this over to the other side, in which then I've got 200 divided by 0.4, and that leaves me with the answer of 500. Moving on to question 13, it says here is an ordinary dice. Ali is going to throw the dice 6 times. He says that I will get one of each number. Give a reason why he could be wrong. Again, it's pretty standard in terms of this one, is because there is an equal chance of getting a number more than once. You could even mention something about each event being independent. So again, you could have a number that repeats itself more than once, and so therefore it's not always granted that you're going to get each number twice. It then says for B, Lucy throws the dice 50 times. Here are results. Work out the relative frequency of throwing an odd number. So let's first of all work out the total number of odd numbers that she threw. So she got 7 ones, 12 threes, and 9 fives. So if I add those numbers up, 7 plus 12 plus 9, that's going to leave me with 19, 28. So it's going to be 28 divided by 50. And then I can either leave my answer as 28 over 50, or I can write it as 14 over 25, or I can write it as a decimal, which gives me an answer of 0.56. For question 14, it says an experiment is carried out 200 times. The possible outcomes for K, L, and M. And it says altogether, well, in the first part it says complete the table. So we know that all of these numbers have got to add up to 200. So for this here, all I've got to do is do 200 minus 84 minus 54. So 200, take away 84, take away 54, leaves me with 62. And then for these numbers here, so for this one, I've got to do 54 divided by 200. So 54 divided by 200 gives me, as a decimal, 0.27. And 62 divided by 200, which gives me an answer of 0.31. Then says, altogether the experiment was carried out 500 times. How many times would you expect the outcome to be K? So it's going to be 500 times, which is the total number of trials, multiplied by the relative frequency of K, which is 0.42. So 500 times 0.42 gives me an answer of 210. Moving on to question 15, so it says that a spinner has spun 200 times. The relative frequency of landing on a 4 after 50, 100 and 150 and 200 spins are shown. Which relative frequency gives the best estimate of the probability of the spinner on landing on a 4? And the best estimate is going to be the last one. So it's going to be 200 spins or 0.16, and the reason for it is because the bigger the number of trials, or the more number of trials, the more accurate the probability. Then for question B, it says how many times did the spinner land on a 4 from spin 51 to 100? So for this, what I need to do is work out how many 4s did we get for these two values. So from the first 50, it's 0.14 times 50, which is 7. And then for the first 100, it's going to be 0.13 times 100, which is 13. So then what's the difference? Well, it's going to be 13 take away 7, which gives me an answer of 6. Then moving on to question 16, which looks at a tree diagram. It says 2 ordinary fair dice are rolled. Complete the tree diagram. So again, if this branch here is 1/3, then this is going to be 1 take away a third, which is 2/3. This is going to be 2/3, that's going to be 1/3, and this is going to be 2/3. The next question then says work out the probability that both dice land on a number that's less than 3. So here I'm going to be using this and this. Now again, and means multiply, so it's going to be a third times a third, which gives me an answer of a 1/9. Now moving on to question 17, which is virtually exactly the same as question 16. The only difference is we've got a high level question for part C. So let's just quickly complete this up. So that's 2/3, that's 2/3, that's 1/3, and this is 2/3. Then that first one is exactly the same, so it's just 1/3 times 1/3, which is a 1/9. The next question then says work out the probability that exactly one of the dice lands on a number less than 3. So we're either looking, now exactly one is going to be either this combination here or this combination here. So it's either going to be a third times 2/3 or 2/3 times 1/3. Now working this one out, it's going to be 2/9. Or means plus, so that's also going to be 2/9. So the answer for C is going to be 4/9. Moving on to question 18, it says in a raffle 200 tickets are sold. The tickets are either red or blue. The winning ticket is picked at random. What's the probability of picking is green? So here it's going to be 0 because obviously the tickets are either red or blue. The next question then says 79 children and 90 women buy 1 ticket each. Men buy the rest of the tickets. Work out the probability that a man buys the winning ticket. Well, let's first of all do how many men there were. So for the men, it's going to be 200 minus 79 minus 90. And again, if I just quickly work that out, I get that there are 31 men. So the probability of a man winning is going to be 31 over 200, or you could write that as a decimal, which is going to be 31 divided by 200, which is 0.155. Moving on to question 19, it says that a spinner has 5 equal sections. Write a number in each section so that the number are all different factors of 100, that the probability of a single digit number is 3/5, and that the probability of getting a multiple of 25 is 1/5. So let's start by actually writing out all the possible combinations. So I could either have 1, 2, 4, 5, and then I could have 10, then 20, then 25, 50, and 100. And then looking at single digits, well, again, the single digits I could either have are going to be 1, 2, 4, or 5. And the multiple of 25 is either going to be 25, 50 or 100. So picking off the first one, in terms of this, I would say it's either going to be 2, 4, 5, 10 and 25 as a possible combination for those 5 possible numbers. For question 20, it says that a bias die is thrown. Here are the probabilities of each score. The dice is thrown 200 times. Work out the expected number of times the score will be odd. So again, here, if we highlight all the odd probabilities together, so it's going to be 0.25 plus 0.15 plus 0.3, and if I add all of those up, I get an answer of 0.7. So then if I then do 200 times 0.7, which gives me an answer of 140. Moving on to question 21, it says that in a running club there are 50 females and 80 males. If a female is chosen at random, the probability she has blue eyes is 0.38. If a male is chosen at random, the probability he has blue eyes is 0.6. One person is chosen at random. Show that the probability of a person who has blue eyes is more than 0.5. So here, let's have a look at this. So what we want to do is work out the total number of people who had blue eyes. So in terms of the men with blue eyes, then that's going to be 0.38, so 0.6 multiplied by 80. And if I type that into my calculator, I get an answer of 48. Then if we then do females with blue eyes, then that's going to be 0.38 times 50, which is 19. Then the total number of people is going to be 80 plus 50, which is 130. Then those people with blue eyes is going to be 48 plus 19. So 48 plus 19 is 67. So then the probability of picking someone with blue eyes is going to be 67 divided by 130. And if I type that into my calculator, work it out as a decimal, I get 0.51538 blah blah blah. So here you can see that 0.51538 is greater than 0.5, and there I've gone on to prove it. Moving on to question 22, it says 4 candidates in an election were A, B, C and D. The pie chart shows the proportion of votes for each candidate. Work out the probability that a person who voted, chosen at random, voted for C. Now this is a pie chart linked in with algebra. So let's first of all work out what X is first, because that's what I need to work out first. So here I've got X plus 2X plus 10 plus 2X plus 90, and that's all got to add up to 360. So collecting the like terms, I've got 5x plus 100 equals 360. So 5x equals 260, and 260 divided by 5 gives me 52. So x equals 52. So I'm working out what each of the sections are going to be. So for C, I've got 2x plus 10. So if x equals 52, it's going to be 2 times 52 plus 10, so that's 104 plus 10, so it equals 114. Moving on to question 23, it says there are 25 counters in a bag, 12 are red, 5 are green and the rest are white. Count is chosen at random, work out the probability that it is white. So here for the number of white is going to be 25 minus 12 minus 5, which gives me 8. So the probability is going to be 8 over 25, which I can't simplify, but if I wanted to give it as a decimal, then that decimal would be 0.32. Then moving on to question 24, it says, at a lucky dip stall, players pick a ball at random from a tub and then replace it. The tub contains 250 red balls, 230 yellow balls, and 120 green balls. Emma has 15 picks. Work out the probability that Emma wins a prize from her first pick. So the probability that she picks a green ball is going to be, well, the total, which is 250 plus 230 plus 120, which is 600. So then the probability is then that she wins is going to be 120 over 600, which does simplify nicely to give me 1/5. It then says, with her 15 picks, Emma wins 4 prizes. Is this more than expected than the expected number? You must show you're working out. So the expected number is going to be the probability, which is 1/5, times her number of picks, which is 15. And so if we do 1/5 times by 15, we get an answer of 3. So is this more? Yes, it is.